My name is Dror Helper. I am a Microsoft specialist working for AWS. And my job is basically to work with customers on moving Microsoft-related workloads, or as we call them, or projects, to the AWS cloud. SQL Server, Windows, and .NET. I do a lot of work with customers on modernizing and breaking things into microservices. And I also write a lot of .NET code. In fact, I've been writing .NET for almost 20 years. Who is writing .NET code for a living? Okay, that's good because we are going to have code. And the story with microservices is that it's very non-trivial architecture to test because a microservice is combined from multiple parts, multiple moving parts that work together to create some value, hopefully, for a customer. So usually, we'll start with the service, and that service will store information in a database. And that service is being called, usually synchronously, using HTTP, REST calls, gRPC, or whatever you decide. But does not work on its own. A single service is not that different from writing a monolith. So that service is probably also calling another service. And those two services together create something that is also stored in another place, in another table, in another database, maybe using a different technology. And all of that is still synchronous calls. But from time to time, we use queues, and we put information for someone else, a worker or another service, to consume, do some processing, and return a value, or call something else. And probably this system does not run on your machine. It can run on your Kubernetes cluster inside your data center, or in the cloud. So it doesn't even exist on my machine, because if I'm using the cloud, why not use cloud services? For example, I can use Amazon S3 to store files and store big information. And now this architecture cannot exist on my machine. So it's more difficult to take it as it is and test it end to end. And just to add a little bit of complexity, in most projects in which I worked with microservices, you always have external APIs. Those are APIs from another company that you consume to get information and return data. So all of that need to continue functioning. All of that need to work. All of that need to be high quality. And how do you test it? Several places where I used to work, the solution for this was, let's hire a lot of testers, let's hire a test automation team, and let them test everything end-to-end, all the time, regression-wise. And that's a lot of work. It's very painful, and it's not very effective. And in the end of the day, when you think of it, the only one responsible to the quality of their code is the actual development team. Because once a development team has created a microservice, they need to make sure that that service functions according to the requirements. That service continue to function tomorrow after we change things, add features. And we want to do that automatically because as developers, our job is basically to write code, add value, and not to keep on testing what we do. And as developers, we need to focus on the quality of our code. It's not someone else's problem. It is our problem. So what can we do? As I said, one solution I saw many, many times is writing end-to-end automation for trying to test all of the complexity of the system with a bunch of UI automation, getting things out of the database, running the whole system in the cloud or in your cluster. And that's a problem because it does not work. It does not scale. And basically, because there's no silver bullet, there's no one test to rule them all. We have different types of tests. We have different ways of making sure our application functions. And it all starts with what we want to do. What is our need? What we want to verify. So starting from top to bottom, we want to make sure the whole system works. all the microservices, calling databases, external services, cloud services, running somewhere else. We need to make sure all of that work. Second of all, as a team that created a service, we want to make sure that that service works according to requirements, and that service continue to function all the time. We do want to test specific interaction points. For example, I just wrote a very complex database query using Link or Entity Framework, and I want to make sure it works. I'm using something outside of my system, and I want to make sure that that specific interaction works. And finally, we want to test our logic. That's the thing we write in, basically. And, well, the next picture you're probably familiar with. For logic, what we do usually use called unit tests. For interaction, integration tests, service tests, and end-to-end tests. Now, this is the testing pyramid. Who here saw, heard, talked about the testing pyramid before? Quite a few, and it's not surprising. I'll recap. The testing pyramid was created by Mike Cohen. He talked about the fact that we have different layers of tests, different kind of tests, and as you go up the pyramid, you have less and less tests. You have a few thousand unit tests, a few hundred integration tests, and then the numbers go down until we get to end-to-end tests. And there are good reasons for that. But if you ever seen a test pyramid, you might know that this look a bit different. The original test pyramid had only 3 layers. It had unit tests, component tests, end-to-end tests. But I think that in microservices, at least in my experience, we used to start with a bunch of tests of different kinds, and slowly they separated until we got these 4 distinct layers. And that's how I'm working right now, because that's the way I tend to think of them, of those 4 distinct layers. And we need all of them, or at least some of them, depending on your project. We'll get to that. And the reason we want less and less tests as we go up is, well, as we go up, the scope increases. The scope increases logically because end-to-end tests test the whole system, and unit tests test a small part of your system. And it's not that end-to-end tests more, it just tests differently. Because usually with end-to-end test, you get to test from one side of the system to the other side of the system. You don't test the small parts, the exceptional things, the corner cases. It's very hard to do with end-to-end tests. If I want to test what happens when one of my services go down, very hard to do with end-to-end test. I need to kill a service mid-run. With unit tests, very simple. So I need all the layers because the topmost layer tests very deep. They test all the way, while the bottom layer tests very broad, a lot of scenarios. So I need both. Also, runtime increases. A unit test will run for a few, well, not a few, less than a second usually, just memory, small test. End-to-end test can run a few minutes. A few minutes is a big deal. If I have a test that runs for 10 minutes, 6 of those will run for an hour. If I have a test suite that runs for an hour, I can run it at most 6 or 8 times a day. It means that if I have a problem and I just fix that, and I run my test, I need to wait for an hour, and if I didn't fix the problem, I'll find out after that, need to fix again and run it again, and there's a limit to what I can do. It will slow my development if I just rely on end-to-end tests. And I've worked with companies that have only end-to-end tests, which takes 7 hours to execute. You can run it only once a day. You don't want that. You want the balance of all of them. And finally, maintenance overhead. The bigger the test, harder to maintain it, harder to keep it running. Every small thing on the way can cause it to stop working. Also, when the test fails, very hard to know why. With the whole system, finding out why something failed can take you up to a few hours. You need to start reading logs. When a unit test fails, you probably know immediately what went wrong. So we need all of those. We need all those kind of tests in order to make sure that our system functions, and we need to know about that as quickly as possible. Now, no matter which test I write, I want it to have at least 3 things going for it. First of all, it needs to be readable and maintainable. A unit test that is not readable is worthless. Basically, the next time I'll see a unit test or any test is when it fails. And if it's not readable, I won't know why. And I won't see it as soon as I write it. Well, usually I do, but the next time I'll see it could be in a few weeks, months, years. And I need to understand what happens there. Maintainable also means that I need to be able to fix the problem as quickly as I can. And there's a lot of sessions, including my own, about how to write maintainable, readable tests. We'll not focus on that entirely today. A test needs to be deterministic, which means when I run the test 1,000 times, I'll get 1,000 times exactly the same results. It can change between runs. One test cannot affect another test. If I run the test in any order, I'll get the same results. If I run it on my machine, on my fellow developer machine, or in the build server, I'll get the same result. And finally, it needs to be simple to run. There's a huge benefit in being able to press a button and all your tests run from your machine. Now, not all tests can do that for you, depending on your code, depending on the type of test, but you want everyone, development team, to be able to run all the tests. You want your build server to be able to run all your tests, and you need to be as simple as possible. That's it. Talking about ASP.NET Core. Now, granted, you can write microservices any way you can. C# is a very flexible language. But usually, we see at least those three layers. There's the presentation layer being called from outside. It's the thing that comes before the controller, getting the information from the web into your code, basically. Then there's the business layer, where we write most of the code, which is combined out of the logic, the domain objects I use, controller in ASP.NET, infrastructure to make it work, and hopefully a layer that calls other things, other services, databases, and so on. And beneath it, we have the technology we use to do that, HTTP clients and NDC Framework, for example. And outside of our code, at the bottom, those are the external dependencies, where I save my files, the queues I use, the databases I call, other services. All of that need to be tested in those 4 different tests. And each test I have has a purpose. I have the thing I'm testing, and have the things I keep outside of the test, the thing I fake away from my test, basically, or don't include. So starting with unit tests. Unit tests are the simplest thing to talk about. Basically, take units of work from your code, and instead of whatever calling that specific piece of code, I'll add a unit testing framework, and I'll use a mocking framework to fake all the dependencies I don't need in my test, so I can focus solely on the logic. Who here writes unit tests? Always a lot of people in Oslo. Good for you. No, it's good for you. Unit tests you write for you. You don't write it for anyone else. It makes your development work easier. Unfortunately called tests, but it's not exactly tests. So there are tools for unit testing framework, probably using NUnit, XUnit, MSTest, that's a big 3, there are others. A mocking framework, which we use essentially to replace a real class with something that does absolutely nothing unless I tell them to do it. And you can have additional tools, in this case, probably code coverage. Not mandatory, very useful to find out if I forgot to test something. And a unit test will look something like this. Most of you know it. This is XUnit. And the unit test framework, by the way, has nothing to do with unit tests. Basically, running methods. That's what the unit testing framework does. It's a very nice way to run methods. And you mark those methods with an attribute, and usually you give it a good name, because once a test fails, you want to know why. The test name will be the first thing you'll see. And then you break it down, and you can write whatever you want inside a unit test, but it is best practice, known best practice, to have 3 parts. A range where I set up everything. In this case, I'll create a fake shopping cart repository, my gateway to the database, and tell it that when I'm asking for a specific ID to return null, not ideal, but that means that it was not found. And then I'll create 2 real objects I use in this test. Now I use 2 real objects because a unit is not a class and a class is not a unit, not necessarily, when you think about it. In this case, it was not logical for me to test just the shopping cart controller that all it does is a bit of verification. I don't care about that in this specific test, and calls the next class in line, the manager. Always see managers in object-oriented, and does the actual logic I care about. Now, I could have broken that to two different tests, but those tests, at least one of them would be very trivial, and probably just test that I called with those parameters, and those parameters were passed to the next one in line. And this is internal logic. And internal logic we don't test, because if you test the way you wrote the code, it means that when you change the way you wrote your code, your test will fail. And we don't want that. We want it to fail only for bugs. So we don't test internally. Now, finding what a unit of work is, not always trivial. And we can talk about it for another hour. But my rule of the thumb is that if I write a unit test and it's too trivial and relied heavily on internal working, on the way I wrote my code, I probably need to increase my scope, add more classes. And if I don't, if it's very complex to set everything up, probably I'm testing too much, need to reduce that. And that's something you go with. You find that if you run with unit tests in a project for a certain amount of time, you'll notice those things. Then we have the act. Act is the play button, run something, find by ID, and then assert, check that something happened. A simple unit test. And that's okay. Those are unit tests, they test logic. We fake away everything that is not logic. You can fake other things. That's another conversation for another time. And then we get to the more interesting or more complex problems, which are integration tests. Integration tests are still using a unit testing framework, but the objective is different. We don't want to test our logic. We want to test our logic that calls something else, something outside the scope of our control. For example, a database, a queue, a service, a third-party API. And in the beginning, I used to test that end-to-end in the scenario level, and then slowly I found out that that's not the best way to do that, and I prefer just to test the layer that calls that external dependency, because we'll get to testing the whole service later on. And this is an example of an integration test, which looks exactly like a unit test. So what makes it an integration test? Well, the thing that makes it an integration test is the fact that I'm creating a real connection to the database, and I'm calling a real database. And you can see that in the test, and that's perfect. Because when this test fails, you don't really care how I connect it to that database. You just know that I have a problem in the logic of how I'm writing and reading. In this specific test, I'm creating two shopping carts, and when I call find all, get them all back. There are more complex things I can write, but that's good enough for now. Obviously, that's not the only test. I'll need more and more and more, especially in the points where I'm doing non-trivial things. Because with automatic testing, it's all about balance. We are not being paid to write those tests. We write them for our benefit to make sure that the code from yesterday working tomorrow, and that we write in the right code as well. So I'm trying to find the places where there will be a problem, where there will be an issue. I'm not trying to test every integration point in every way, especially not the trivial ones. But I do want to test the things I'm not certain about. Maybe I'm using a very complex code inside. Maybe I'm using a service that I'm not 100% sure works exactly as I expect it to be. And if I'll fake it away, I probably will cheat myself by expecting something to happen, and in the real world, something else will occur. But in order for this to work, I need to do something. And that something is basically, in the beginning of the test, that database was created. We'll talk about that. And then I'll take the connection string for that database so I can use it in my test. And also make sure that in the end of the test, and that is suppose, with X you need to use this pose to clean things between tests. I'll need to make sure that I clean up afterwards. I'm not leaving anything for the next test to fail on or to expect to happen, because I don't want one test to affect another test. And with the integration tests, it's harder than with unit tests, because integration tests are more complex. You have external dependencies. By definition, that's something you don't have full control on. That's something that you need to somehow accommodate with. It's something that you need to create That's something you need to clean up. That's something you need to initialize. And that setup takes time and effort, a lot of effort around making sure that your test runs all the time in the same way with something that is outside of your code. It's harder. It's more difficult to do it correctly. And it takes more time. It makes the test slower from a couple of seconds, which doesn't sound much, but again, 10 seconds times 6 tests equals a minute. So it means 600 tests, do the math. So we make sure that we only test what we really care about, because those tests will be slower. And we have the shared state, because by definition, we're using something outside of our code. So one test could accidentally trip another test, make it fail, or even worse, make it pass. And then you have the test that sometimes passes, sometimes fails, depending on what order you executed your code. And usually with those tests, some developers or not necessarily developers, will try to run them again, everything is fine. And so either you go home happy, or you start to do a binary search, finding out which test affect which test. That's a painful, I did it more than once, very painful thing to do, very hard to do correctly, takes a lot of time, so you want to avoid this shared state as much as you can. And that's a problem, because in most cases, in a lot of places, you have a lot of data in your database, and you need to initialize it. It takes a long time. And you get to a point in which you run your tests on your development machine, on your build server, but on the other hand, you have a database somewhere else, some central database that everybody calls from different places, different tests, and then you have a problem. Now, it's a problem that you can solve in many ways. One way, one company I worked with, way in the past, a long time ago, what they decided is that those integration tests will only do reading and not writing, because they couldn't guarantee that if I run it for my machine and someone else will run for his machine, we won't accidentally cause a problem. And remember, there's also a build server, so if the build is running in the background and I'm trying to run the test on my machine, I might trip the build as well. So that's a problematic thing to do. And there are database technologies that are very hard to deploy on your machines, either because of licensing or because they are very complex to run on your machine. Or your database schema is very complex, very hard to recreate from scratch each and every time. And there are ways around it. Restoring your database before your test is one of them. Another is, why not run the database in your machine if you can? And if you can, run the database on your machine. Even better, run it inside Docker. Because with the ASP.NET Core, I know one thing, most of you have Docker for Windows on your machine, right? We have Docker for Windows installed, so use it in your tests. Docker is an excellent way to set up infrastructure, run a test, and then throw it away. And it's very simple to do. There are a bunch of NuGet packages and projects in GitHub to do that. Or you can do what I did. Just run Docker, right? Before running, and MongoDB is a very easy database to set up. Before running your test, that's the constructor here. Well, I'll run Docker with the image I need, with the data I need, and then when I get to the test, the code from before, I'll get the database connection string, start running as if I'm running unit tests, knowing that this database is already up and running. Very important when you do that is two things. First of all, in the end of the test run, when you finish running all of your tests, make sure you clean up. You don't want the second run to leave things behind. That's first of all. So you need to clean everything up after you finish running all of your tests. You don't want to restart a Docker image each and every time. That your test will take minutes. You just want to set up once and then clean up when you've done. And sometimes if you stop your test run mid-run, you'll need to do that manually. But that's okay. We know how to write Docker stop. And another thing you need in between your tests, and that's in the test suite, that's the code we saw before. You need to make sure that after each test, or before each test, you clean up everything, or at least return it to the initial state. Here it's very simple, I just drop all the tables. And that way I can make sure that one test does not affect another test. And I run on my machine or on the build server, no one else runs with this database. So I just reduce a big chunk of the shared state dependency. The only shared state I have here is basically the fact that I can't run the same test that use that database in parallel, which I might want to do, but then maybe I need to break the test differently to do that. Okay, what about cloud services? You know, I work for AWS. I have to talk about cloud services at least a little. Let's say I'm using a queue. In AWS, I have many ways to do queues. One of them, SQS, simple queue service. AWS, everything, simple or elastic, or both. So simple queue service, I have a test. It will call one server. That server will queue a message. Another service will take that message and do whatever. So basically, the left side on my machine, right side on the cloud, and the other service, well, we don't need it right now. We are testing integration test. I don't need the rest of the line. Just need what I'm testing, just the scope. I need to reduce the scope in order to have a more maintainable deterministic test. So one way is to do exactly that. I'll keep the queue in the cloud. I'll make sure there's a queue there when the test starts. I'll set everything up. I'll run my test with the cloud. And then, in the end of the run, make sure there's nothing left afterwards. Clean up after myself. I don't want to pay for something I'm not using. And that's okay. That's one way to do that. Not the only way. Because these days, at least I know myself, I use quite a lot of, I call them local AWS services. You have projects, many projects. Write the service name in GitHub. You'll find people wrote something that mimics that service that you can run either in your code or in Docker and work with. For example, with Q, there's Go AWS that does a very good impression. It looks exactly like using a queue. You just need to point it to the thing that runs inside your Docker, inside your machine. And you don't need to run with the cloud. You can run just on your machine, and you don't have a shared state, and if two people run at the same time, not accidentally hurt each other. Another way to accommodate for the fact that we're running in the cloud is probably to use unique identifiers. I'll create one queue, add a timestamp, a GUID, or something for that test, pass it to the test in order to connect. Another test running in parallel will create a different queue with another name. And that is also a possibility, also something you can do. And you use test fixtures, just like we saw with that database. If you work with the cloud, in the setup, you want to create a table. This is the DynamoDB object database AWS interpretation. So you create a table, you run your test, you destroy the table. Add timestamp or GUID and make sure that no one else create the same name for your table while you're running. Or use Docker. You do use Docker start, create a table using AWS DynamoDB local. That's a project you can run in Docker that looks and behaves like DynamoDB in the cloud. And exactly run the same test, set up whatever you need, create a new table, start working, finish working, clean the table, and at the end of the day, Docker stop, Docker remove. Now there's pros and cons to using each of those options. The first, if I'm using a real service, obviously, it's more accurate. No matter whatever you run in locally, it could be one of the many options. It will never be exactly like the service. Some of them don't have the full functionality. All of them don't have identification, for example, because they're running on your machine. They're not authorizing you. But it means that you might pay money if you run enough tests. That we're talking in the hundreds and thousands, but it does happen in big companies. And you get latency because you call in the cloud back and forth all the time. The challenge is what happens when two people run in the same time. We talked about that. On the other end, running on your machine. Very consistent because I have full control. I took the control, put it on my machine. Docker start, run, Docker stop. It's very fast. Well, it's faster, but mostly for business logic. So something to comment on, you don't need to test AWS services. They work. You need to test the integration, the interaction with them. So testing only business logic, probably good enough. Okay? And the same for every third party or additional tool you're using. It's partial, And always initialization, again, with Docker, that's the way we do that. And that's how I do integration test. When I can, I use Docker. There are a lot of projects for some of those tools that you can run directly from your code. And you make sure that you get as much control as you can, because those tests are very fragile because they depend on environment. Which brings us to the third option, service level tests. Here I want to test the whole service. One service, top to bottom. Controller all the way to when I exit the service, basically. Again, I can do that with a unit testing framework, because a unit testing framework has nothing to do with unit tests. It's just running code, running methods. But the question with service tests is, what do I fake and what do I keep? For example, let's say I have that MongoDB database from before. Do I want to create a real MongoDB database, or do I want to use something to replace it? And that something can be all the options we just saw with integration in unit tests. Or you can say, well, the database is a big part of my service. Why not start one using Docker? Why not have it installed beforehand? And that's a valid point. The only thing to think of, though, is if I am doing that, just remember that I already did those integration tests in the perfect world. And if I already did those integration tests, I don't need to retest everything I already tested in integration, because the objective here is not the actual integration, but the whole service. I want to make sure that if I execute something from outside to my service, will go all the way through the service and return whatever I needed to return. I don't test the database in this case. I just test the return value or the methods being called outside to someone else. So it's a bit different, and you shouldn't have the same tests just with all the service as you had before with unit tests and integration tests, because that's just wasting your time, and your time is more valuable than doing the same thing over and over again. Another good thing with the ASP.NET Core is test host. Anyone here ever used test host? Excellent. I just found out after I did 2 projects where I did it manually. Test host essentially, it's a NuGet package. You add it part of ASP.NET Core. They manage it. Basically allow you from your code, from your test, well, you can do it not from a test, you can do it from any piece of code, start your service. And I use it now all the time. I use it because I will start my service from my code. This is the code I have before running the test in my test feature initialize. It will start a service, and the nice thing, it will give me a client already wired to use that service. I can use that client, that's an HTTP client, regular HTTP client, already pointing to the local host, whatever port that this service was created in. Saves a lot of time because I used to do that manually. And once I have this client, usually what I do, I'll wrap it with another class and add all the different capabilities, or if I already written a client library, just pass this HTTP client to it. So I can call the methods just like the actual other services that are going to call my code. And I call it from outside using HTTP this way. And I set it with my test. Now there are other services, and this is this slide. The other services I don't want yet. I want to fake away all the services, and there are very good projects to mimic HTTP services. WireMock.net is one of them. The other one is called mock server. And essentially, the way they work is that I set an expectation beforehand. I'll tell that service, when you get this call, this is what you need to return. And then for my test, my unit testing framework run test, I will call my service that I just set up with the client I just created. And that service, my service, will call that fake service because I fixed that with my configuration. It will call it and get a return and get all the results back. So my service now works in a controlled way where I fake every other service in my microservice architecture in that specific test. And most of those fake servers also enable me to assert that a specific call was made or not made, if that's what I need to do. I want to check that if A plus B happened, then it called a different service that need to continue performing some operation. And in fake service, very easy to set up from your code. You don't need to exit code, no Docker involved. And this is how I set it up. It's a mock provider service with wire mock. Wire mock is one option. Mock server is another one. You can form your code. And by the way, it's not only .NET, all of those has libraries for different languages. And then you can say something like this. I want to set that a product is missing. So if someone calls my API in that specific URL, I can say with parameters, with query string, with body, whatever. Then this is a response you're supposed to return. Now, when my test will run, the real service I'm testing will call it and get that response back. So I can test my microservice infrastructure without actually setting my whole infrastructure in place. Very beneficial because if the test fails, I know exactly who to blame. That service has nothing to do with the other services. Very easy to set up and tear down, relatively fast. Very simple to use. If you ever use the mocking framework, the same with the URLs, basically. The problem with service level tests, they become very hard to read, very hard to maintain, because you need to set up a lot of things and you can accommodate with that. You can create, and I've talked about that in the past, you can create factory methods, that's one option. You can create builders to create your different objects. You can do a lot of things up to a point, but still you need to do quite a lot, and this is a relatively small, simple test, and if you can't immediately understand what it does, perfectly logical, because it's too long and I needed to break it into two parts just to put all the code. And if you really look inside, you'll see that I didn't write all the code because it's too confusing to do that. Please ignore the test name. That's not a good test name. I ran out of space. Basically, I need to initialize everything. I need to set things up. I'm using a real database in this case because that's what I decided to do. I'm calling a client, but I encapsulated it so everything you see as _server, that's my class calling, using the client to call that server. So there's quite a lot of code in the back working that you don't see, and it's still too long. So what can I do with very long tests? Well, I can try to reduce that because you don't care about most of what's happening in this test. We want to understand what is the scenario I'm testing, what I did, and what I expect to happen, right? Arrange, act, assert. Very hard to see when you have very complex setup. And you can encapsulate some of it, but at some point you start reducing the readability of your test, because if I would have set the whole system in the background, no one would know what I'm doing. I had one client 15 years ago that we talked about shortening his test a bit, and I told him some of this in initialization, boilerplate code, you don't need to see it in your test. Went back as a consultant. I used to come once a week there, came after a week. All the tests were 3 lines, exactly 3 lines. Set up environment, test the system, check results. And each and every one of them got 20 different parameters to pass in. That's unreadable, impossible to maintain. You don't want that. So what can you do? Well, I found out that there's a tool that was created for something completely different that is very beneficial of helping me focus on what matters in the test, and that's BDD Frameworks. Anyone here used a BDD framework in the past? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, not bad. SpecFlow, anyone? Okay, yeah, I use that quite a lot. BDD anyone? Okay, I'll talk about that. So BDD framework, essentially, we split the test into 2 major parts. Well, we break it into multiple files, but 2 parts. First part is definition of different individual steps, building blocks. Those building blocks, this is SpecFlow, are essentially methods with this attribute before that tells the text that this method represents, the part of the story of this method. The first one, I have a customer of some type with address. And those parameters will be passed magically here. That's SpecFlow problem. And the second method, the customer asks to calculate how much he need to pay, basically. And again, here we don't have anything in the component, and a bunch of fields happen in the background. Now, writing this code enabled me to write the second part, which is the specification, which is this code. And this is more readable, and it's exactly the same test I showed you with the unit testing framework. Now, SpecFlow, all of those work inside the unit testing framework. That's what runs it. But they add another layer that helped me understand what the test does. You get all the information you need. You know exactly what type of customer, what type of coupon, what I'm doing, what's the result, what's the number I expect. And if this test failed, I get a very good error message telling exactly what the problem is. But you don't know how I'm running it because you don't care. You know, if you need to debug the test, you'll debug the test. But most of the time, you just want to know that this worked, and if this does not work, if, for example, we'd get 1,000 and 100 in the end of the day, not 1,000, I know there's a problem with free shipping coupon. Okay? Hopefully, a bunch of unit tests will fail as well. And by using a BDD framework, I can make sure that I can read the test easily. Now, not all developers like this separating of concerns, writing the steps on one end and writing the feature file. This is a feature file on the other end. And I get it. It feels like doing the same thing twice. And for that, there's a framework you should try called BDD. BDD enables you to write this specification in C# in your code. But you still hide how you do the different steps. But by writing it in English, it forces you not to go overboard, and the things, the code in the background, will do exactly what you expect it to do, because it's very hard to cheat yourself, basically, and write one thing and then do something completely different. And it's debuggable, and it's supported. There's extension for Visual Studio to run SpecFlow. Context highlighting. And it's a good way, the more scope you test in your test, the bigger your arranged part will be. You need to initialize more of your system. And so your test will become very big, very long. With end-to-end tests, you definitely want that because this is basically a description of a feature. This is a requirement written in sort of English. Well, we don't talk this way, but we can read it. And you can even show it to your customer or your product manager and say, does that behave as you expect? Now, ideally, those tools were created for the product manager to write the specification and then the developer implement them. It happens from time to time, but not all product managers like to write this way. But it's still beneficial in order to get your test under control, to have a concise way of explaining exactly what we're doing. It will also force you to define your service. Because once you write those tests, you'll notice if your service does things that you didn't expect it to do. If you added code because it was convenient, that has nothing to do, in this case, with the shopping cart. Okay? I'll start seeing words that are not shopping cart. I'll know my service is doing something outside of its scope if that service is called shopping cart service. Okay? And then we get to end-to-end test. Now, end-to-end test, a lot of people don't like to talk about them. I get it. End-to-end tests are complex, very hard to maintain, very hard to keep on running. Takes a lot of time to fix when they fail and find out the problem. For that reason, a lot of companies have a dedicated job for automation tester, automation QA automation, so on, because it requires more work, and you can do that without understanding actually how it was implemented. Because it testing from the outside, you don't touch anything inside your code. You run services in the control system. Probably those services will call other services. You might choose to fake services, but you do that outside of your code. So it can be handled by someone which is not the development team. Depending on the company, some believe that a single team does everything perfectly valid, and then the automation is part of the team job. And some believe that that's a different department, a different specialty, different someone. Well, it's up to you. It takes more to maintain. It takes a longer effort to create. They run longer. And that's why we write less of those. And by the time we got here, passing through unit tests, integration tests, and scenario tests, probably don't need as much end-to-end tests. We just need a few. Test the major flows through your system. Don't test all of them because you already tested your logic. You already tested your services. You don't need to do that yet again in a very difficult to do way. Test the things you really care about, where the most value for your company exists. And this is the end-to-end test. And in fact, I done more than one project where we had 0 end-to-end tests. We didn't need them. It depends on the size of the team. Usually also if one team creates the whole system or different teams create this huge system together. But you do need to consider them only after you already done your homework, already done the rest of those tests. As far as structure inside your code, you want your unit test, integration test, and service test to be with that service. Compile with it, deploy, run with it in your build on your machine. Unlike end-to-end test. End-to-end test you can decide because end-to-end tests usually don't run on your machine. You need to deploy first and then run. So basically what you'll have in your continuous integration is build, test, all of the tests up to service level test, deploy, then run the end-to-end test if that's what you need, all of those. I did find it very useful to distinct between unit tests and integration tests for me. So I'll write the file name for where I host the test with either unit test or integration test, just so I'll know which is which. Because once you do your job properly, you won't notice in a glance if a test is integration test or a unit test, and I don't want to mix them. I want the ability to run only unit tests, only integration test. I want the ability to do whatever filtering I want. And that's basically the project structure. And that brings us to a more complete list of testing tools. So with test runners, unit test is the base. You can use BDD Frameworks. If you do end-to-end tests, probably you need browser or UI automation as well. With faking, mocking framework is the start. But you'll get pretty fast for mocking the whole services for other services and local services if you use a cloud or some third party. A lot of companies that provide third-party APIs do provide those. And if not, I did use the fake HTTP service to do that for me. And finally, well, statistics, up to you. That's an endless list. This is a very short one. Code coverage, Visual Studio has code coverage built in if you use the professional enterprise editions. Dot cover from JetBrains. Your build can have static analysis, additional reporting. It's an endless list. Whatever you add, just make sure it adds value and that people look at it and are aware of it. If you just added, I know, SonarQube and it found a bunch of critical problems, someone needs to address that. Someone needs to be aware of that. But other than that, this is a very short list of what I use in .NET. Which brings us to a tool I didn't talk about. Anyone here ever use PACT? P-A-C-T. Excellent. 2 people. For a very good reason, which I'll explain. PACT is meant to reduce the overhead of doing end-to-end tests, especially when different services belong to different teams. Because the big problem we have with microservices is when someone accidentally or intentionally changes the contract. The messages I call from one service to the other, either directly or through a queue. And PACT is created for the HTTP part. And the idea with PACT is that during the arrange set, I'll use it just like with the mock server, HTTP server. I'll set expectation. When this call is being made, this is what you need to return, HTTP-wise. And that will create a contract that is saved by PACT in files. And then I'll run my test, call it. It will get the information I need from PACT, and everybody's happy. And I'll get the results. But there's the other side of the different team. Another team will go to PACT, and PACT will create unit tests. Well, unit testing framework run tests to run against their service according to the expectation I just set up in the different team. So I need a central PACT server that both team calls. One creates how they expect to call the other one, and the other one running that as tests to make sure that this line is not broken. It's a very cool idea. Unfortunately, getting back to work requires a lot of work on your behalf, and you need to be aware of that. And it makes a lot of sense when you have multiple teams, each doing his own service. But there's a way to accommodate for that. In many projects, just having a client library, responsibility of that service team being distributed to other services free and NuGet is good enough. It might be good enough. If you find out that you get a lot of problems, contracts are always getting broken, you need to find a way to fix that. It can be done either in code or through contract testing, these kind of tools. If it's interesting for you, Google it. Try it out. It's a very interesting tool to use. But if you're doing TDD and you expect it to immediately update and then send the test on the other end, you'll be sadly surprised, like I was, because it wasn't meant for that. Two different teams working individually, isolated from one another. That's the reason it was created. And not one developer writing test one end, running on the other end immediately. So going back to the picture we had in the beginning. So I have this system, it has cloud services, it has multi-services calling all ways. So what do I test, how they test? Logic, I'll write unit tests. Each service logic should be tested by unit tests. Then the interaction where it matters, where I have the more complex code or calling non-trivial services for non-trivial API, or doing something which is critical to my product, then I want to write those integration tests because they are harder to maintain. And service tests for each service, where I get to choose what I fake and what I leave. And finally, end-to-end tests, but not necessarily for the whole application and all the scenarios, just what is basically left out. What I'm not testing or tend to break or is very important to the organization should be used with end-to-end tests. And this is basically what the testing strategy should look like. Now, it looks like a lot of work. Putting end-to-end tests aside for a minute, just once you get the hang of it, writing unit tests, well, most of you run unit tests all the time. Getting the first test with the integration test, usually the harder, getting everything set up correctly, but then you just write more and more tests. And service tests, which are relatively simple to write, again, because you already know what to do with all your dependencies, that's the hard part, can be very fast. And I've been part of teams that managed to do that as part of the development effort without decreasing our speed, our agility, basically. Because it's just like with unit tests. In the beginning, it's hard. It takes a while to understand how to do that correctly, and they tend to break. But then once you get the hang of it, you keep on writing more code and more tests and more code and more tests, the same for each and every level. It's not a lot of work once you know how to do it, and once you try it for a few days. Well, that's it for me. I'll be happy to answer any question, but before that, if you want to learn more about .NET on AWS, I'm part of that. We have a nice developer center where there are free books there and training that you can use. And we also have a booth here if you want to hear more. And if you have any questions, I think we have 5 minutes. I'll be happy to answer any question you have. Yes, with the white. Yeah.
Where do you think load testing/layer testing fits into that?
You have to speak louder though, because my hearing is not that good.
Where do you think load testing?
Okay, load testing. Where does it come to play? Okay. Well, load testing is a different thing altogether. Probably done on the whole system, or at least a functioning part of the system running in the actual environment, not on your development machine. You can do those automatically, but usually, in most cases, you want to do that, in a well thought of event. Here I only talked about correctness and not necessarily non-functional requirement. That's it. Security as well. There are tools for that as well. So it comes in a different place. Now, with load testing, It's not that you don't necessarily need it, but it depends on your project. I did a project that had 10 concurrent users. You know, we used a solid foundation here, probably will work. So we didn't need as much load testing, but if you want to accommodate 1 million users, well, you need load testing, but you need to plan for that. You need the infrastructure in place. If you have auto-scaling, you need that and everything in place, and then probably you'll run it, you know, and look at it. It won't run in the background every night, unless you put a report there, but that's a different story altogether. I had another question in the back. Anyone?
Yeah, I was wondering about smoke tests. Are they
Okay.
seen as part of the
Yes.
end test?
Well, the question was, what about smoke tests? Where did they come into play? No. Something I should have emphasized more. The names I gave those tests are not necessarily the names everyone uses. I call them unit tests, integration tests, service tests, end-to-end tests. Smoke tests is a way to define a test that I run to make sure that everything, or a canary test, you know, nothing break immediately when I run it. Most of the time we're talking about end-to-end test in this case, because I want to deploy and run the test on wherever my environment is, make sure everything works. And by definition, they are not a full suite, but something that checks the major parts, so it's very similar to end-to-end tests in this case. If you write unit tests, you shouldn't define them as smoke tests. You need unit tests for all your logic, basically. But it's not always possible or not a very good way to spend your time, especially coming to an existing project. And then you pick the places where you care about, where you change things or where you get a lot of problems. So you can call that smoke test as well, if you want. But those names are changed depending on the book you read, the site you visit, the speaker you talk to. You know, those names are not absolute. Just keep that in mind. Any other questions? Any more? Yes. So.
Do you see any problem with an approach where you would combine integration and service tests altogether?
Do I see a problem with having service tests and integration tests? Well, basically, no, and do whatever. Well, some projects, it's more logical than others, especially if you have less logic in your service level. For example, you get data from the database, show it on a website. There's no real logic in between. It's not logical to start writing unit tests, integration tests, you know, maybe your queries are trivial. And the database, for example, in my service test, most of the time I do have a database there in place because it's easier than faking it away. Do whatever is simpler for you and makes sense in your project. You might end up in a project that has no integration test or no unit test. That happens depending on your logic. You know, you have to spend time where it makes sense, basically.
Thank you.
You're welcome. Yes. If you have any more questions, I'll be here. I'll be here tomorrow. You can come and ask whatever you want. Thank you for the time. I know it's late.